Hello, and welcome back to A Pint of Astrobiology, the show where I discuss the latest conundrums in the field of astrobiology over a pint of beer. My name is Ben Pierce. I am an astrobiologist, an amateur brewer of beer, and your humble host. And today I'm drinking a German Pilsner, which is a classic style in Germany, a pale lager, which has a very crisp and clean flavor profile, and a moderate amount of hop bitterness, which is classic for the style. Finishes somewhere on the moderate side between dryness and sweetness. Oh, yeah, I could drink that all night. In today's episode, I will be discussing the potential detection of life in Venus's atmosphere and the controversy that surrounds that detection. And I'm also going to let you in on a little bit of metaphorical schoolyard fighting that occurred between scientists due to the detection. But first, how was life potentially detected in Venus's atmosphere? Well, while observing Venus, astronomers such as Dr. Jane Greaves and her team detected phosphine, the biosignature gas, via its spectral line using the spectrometer aboard the James Clerk Maxwell telescope atop Mauna Kea in Hawaii. Here is the signal in all of its glory. And the red line you see there, that's a simulation to show what a phosphine detection of about 5 parts per billion would look like. Now, there was also a potential detection using a different telescope, ALMA, which is much more higher resolution, much more sensitive, and is actually a collection of 66 radio telescopes that work together as one giant telescope. However, astronomers have not been able to reproduce the ALMA detection independently using the same data. And in fact, Villanueva et al. Wrote in their paper, "We ultimately conclude that this detection of phosphine in the atmosphere of Venus is incorrect, and invite the Greaves et al. Team to revise their work and consider a correction or retraction of their original report." Oh, shit. Anyway, Villanueva apologized on Twitter, but you best not be going inviting scientists to retract their work publicly. It's basically the scientific equivalent of a slap in the face. Anyway, the James Clerk Maxwell telescope detection has been reproduced independently by many groups of astronomers, so scientists are in fact fairly confident that the phosphine is in Venus's atmosphere at about 55 to 60 kilometers above the surface, and that it has about a concentration of about a part per billion or so. Why is this detection cool? Well, on Earth, there is no known source of phosphine except for life. On Earth, we have phosphine produced or associated with ecosystems that contain very little oxygen, such as rivers, lakes, wetlands, landfills, and animal intestinal tracts. And it builds up in the lower Earth's atmosphere to about the part per billion range. But you may have heard that Venus's surface is a literal hellscape, with temperatures of 475 degrees Celsius or 900 degrees Fahrenheit, and an atmospheric pressure at the surface which is 92 times the pressure of Earth's atmosphere at sea level. So how could life exist in such a uninhabitable place? Well, it would have to live high up in Venus's atmosphere, where the temperatures are much cooler and the pressure is more like Earth's pressure at sea level, somewhere between about 50 and 60 kilometers above Venus's surface. You know, in Earth's atmosphere, there's tons of bacteria and fungi floating around at those same altitudes, but they are likely in a dormant state in Earth's atmosphere because it's frickin' freezing up there, whereas in Venus's atmosphere, it's more like between 0 and 60 degrees Celsius, between 50 and 60 kilometers above that surface. So if bacteria could make use of, say, updrafts to maintain its altitude, it could theoretically survive in this habitable layer in Venus's atmosphere. Now, it's not exactly a believable solution, even for the optimist, but something has to explain how that phosphine got into Venus's atmosphere, and life is one possible explanation. Other possible solutions include unknown chemistry, volcanic eruptions completely different to any kind of volcanic eruptions we see on Earth, and that a giant iron asteroid impacted Venus's surface in the last 1,000 years or so. Scientists are working hard to model these scenarios so they can try and cross some of these off the list and try and find the most likely solution for the phosphine in Venus's atmosphere. But let's say we're able to cross these all off the list. Does that mean that the most likely solution is that it's life in Venus's atmosphere? If you were to maybe quote Sherlock Holmes or Spock in this scenario, they might say, "When you have eliminated all which is impossible, that whatever remains, however improbable, must be the truth." But I think that's a load of bullshit, because the onus is always on the scientists to prove, beyond a reasonable doubt, that we have detected life, extraterrestrial life, beyond Earth. Not to disprove that we haven't found life. You see the difference? What we need to do is actually go back to Venus, take a sample from the habitable layer in Venus's atmosphere and try and detect biomolecules produced by life. Or, even better, collect a sample and bring it back to Earth and potentially have this sample of Venusian life on Earth. Only then can we be for certain that we have detected life in Venus's atmosphere. I'll say cheers to you, and that's all for today.